Hi everyone. In this video, we will have the secant and the cosecant functions. So consider the function y equals secant x. Recall that the secant of an angle is 1 over x, or the x coordinate of the terminal point on the unit circle. So let us give values for x and solve for the corresponding y values. So when x is 0, that means to say the angle is 0. So here we'll look at this. So 1 over x. So 1 over 1. So that is 1. So we have a point 0, 1. So 0, 1 is here. Okay, when x is pi over 4, meaning to say the angle is pi over 4, so we will have 1 over this. So 1 over square root of 2 over 2 is square root of 2. So you can verify that. Square root of 2 is about 1.4. So here, so pi over 4 here, and then 1.4. Pi over 2. So when x is pi over 2, we have 1 over 0. So 1 over x. So 1 over 0 is undefined. So pi over 2 is not in the domain of y equals secant x. If x is 3 pi over 4 here, so 1 over this, so negative square root of 2, so negative 0.4. Negative 1.4. And then when x is pi, so 1 over negative 1, so that's negative 1. So pi negative 1 is here. And then 5 pi over 4, so 1 over x. So 1 over this is negative square root of 2, or that is negative 1.4. So it's here. And then if x is 3 pi over 2, so 1 over 0 is undefined. So 3 pi over 2 is not in the domain of y equals secant x. And if x is 7 pi over 4, so 1 over square root of 2 over 2 is square root of 2. So that is positive 1.4. And then when x is 2 pi, so 1 over 1 is 1. So we have this. If we'll give more values of x and solve for y, we can draw the graph of that looks like this. So you will have it here and then here. Okay, so for the domain, okay, we can have any value except pi over 2, 3 pi over 2, and 5 pi over 2, 7 pi over 2. So all the odd multiples of pi over 2 are not allowed. So same with the tangent function. So all real numbers except odd multiples of pi over 2. For the range, as what you can see, we will have here we have from negative infinity up to negative 1, and we don't have values between negative 1 and positive 1, and then we have again values from positive 1 to positive infinity. So we have for the range negative infinity to negative 1, including negative 1, union 1 to positive infinity. So set of all real numbers except those that are between negative 1 and 1. So that's the range of the secant function. And then for the period, that is 2 pi. So one whole cycle will be every 2 pi units. So after this, you will repeat again with the graph. You will have again another like that, and then here. So if you will complete, this is one cycle, the red one. And then if you will extend that to the right, you will have this and this, the gray ones. And if you will extend to the left, you will have this, this, and this. So take a look at the connection of y equals secant x, this and this 3 here and this 3 here. Of course, there are more. And the cosine function, since they are reciprocal of each other. Cosine of the angle is the x coordinate. Secant of the angle is 1 over x. So the values are actually reciprocals. So if you will have this, the cosine function as this, they just meet here. The lowest point here up here of the secant is the highest point of the cosine. The lowest point of the cosine here is the highest point of the secant function. So that's it for the secant function. That's how the graph looks like. And then if you will have numbers here, your values will just be, for example, if you have a number here, 2, your value will just be multiplied by 2. So instead of 1 here, it will be 2. So the lowest will be here, and so on. And then for the cosecant function, okay, so this is not like the sine and the cosine functions. The discussion here are just limited. Okay, so we have cosecant of the angle is 1 over y. So 1 over y. So let's give values for x and solve for y. So when x is 0, so y here is 0. 1 over 0 is undefined, so no value for x equals 0. If we have pi over 4, so 1 over y, 1 over this is square root of 2. So that's about 1.4. When x is pi over 2, so we have 1 over 1, so that's 1. So pi over 2, 1 is here. And then 3 pi over 4, so 1 over y. So 1 over square root of 2 over 2 is square root of 2, so that's 1.4. So it's here. And then pi, x is pi, so 1 over 0, undefined. So no value for x equals pi. And then for 5 pi over 4, so 1 over this, so negative square root of 2. So negative 1.4. For 3 pi over 2, 1 over negative 1, that's negative 1. So here. And then for 7 pi over 4, 1 over this, so that's negative square root of 2 or negative 1.4 here. And then for x equals 2 pi, 1 over 0, it's undefined. So we don't have values for 0, pi, and 2 pi. So if we will give more values for x and solve for y and connect them, we will have this kind of graph. And of course, it will repeat again here and then here and so on. So this is one cycle, it's like a pair. One cycle from 0 to 2 pi. So the domain, we are not allowed to have values of x that are equal to pi, 2 pi, 0, negative pi, 3 pi, 4 pi, multiples of pi. So all multiples of pi are not included in the domain. So the domain can be is the set of all real numbers except multiples of pi. For the range, it can be any real number except those that are between negative 1 and 1. So negative infinity to negative 1, union 1 to infinity. And then for the period, that's 2 pi. And then, okay, if we will have a look at it together with the sine function, their connection is the same with the cosine and the secant. Okay, so this is how they look like. The gray parts here are the extension to the left, and this one is to the right. So these are still part of the cosecant function. So this is how the cosecant function looks like. So that's it for secant and cosecant functions.